Video on Professor Gary Bernstein at the University of Notre Dame. I'm going to show a few more things. So let's turn off the two outputs. I'm going to show you just some basic functions. So here I'm taking the output from the function generator, and it's going to plus and ground. And it's important to know something about ground. All of the metal that you can touch is ground. All of this metal that you can touch is ground. These happen to be signals coming out, and they're metal, so that doesn't count. But just about every other metal that you will ever touch that's connected to equipment is ground, and the black wire is ground. So we want to keep that in mind. So here is the output of channel 1. I'm going to plug that here into this circuit that is what you're going to build in lab 2. And I've already got it hooked up, so I've got the ground and the plus, and that's connected to everything. And I'm just going to demonstrate the use of an oscilloscope probe very quickly. So getting myself a probe, and it's a really nice BNC connector at the end. This was made for the oscilloscope, so it knows certain functions built into the probe for the scope. I plug that in, turn it. Never force anything. If it doesn't work smoothly, a finely engineered piece of equipment, then there's a chance you're doing something wrong. Now, do I need to connect ground when I use the probe? The answer is I don't, because this ground and this ground are the same ground through the same ground circuitry in the bench and in the walls and on all the metal parts. So if I were to connect this to ground, it would just be like connecting the same piece of wire to itself. It wouldn't matter. This piece of metal is just an extension of this piece of metal and this piece of metal and this piece of metal. So I don't have to connect it. If I wanted to, it wouldn't hurt anything. There are things called ground loops, so yes, it can hurt something, but we're not worried about that. So this is ground. It goes to this wire. It's coming down this rail, and it's going to here. So this, in fact, is the exact same ground. But when I do that, I can at least see what it's in relation to. So when I connect the probe, you pull back on the spring-loaded mechanism, and the hook is exposed. I'm going to hook that to this point of the circuit. Now that point of the circuit is the voltage. So what we'll see when I turn on the output is we'll see the output of the function generator. That is the output of the function generator. And there it is, the sine wave. Now let me show you that if I select the frequency and I decrease the frequency, it spreads out, because a lower frequency is a longer period. That means the sine wave gets larger. A higher frequency, notice there's a delay. It's because the data is being stored and it's going into the computer, and the computer's displaying it. So these are higher and higher frequencies, and they're closer and closer together because you have more periods per unit time, and that is a higher frequency. Let's also change the amplitude. So I select amplitude, and I'll move the digit over, and as I decrease the amplitude, the sine wave voltage gets smaller, and as I increase the amplitude, the sine wave voltage gets larger. So that's voltage and frequency. And all of that, through this probe right here, is just connected to this wire here, which is also the same as this wire, which is the same as this wire, which is the same as this wire, which is going to the output of the function generator. So let's look at this voltage. And we can select to display the whoops, not that one. We want to measure. So we want to measure the amplitude. So I pick P1, and I can from this menu select, if I can move it with my finger, the amplitude. I select the amplitude, and now the amplitude is being shown as 4.2 something volts, and as a matter of fact, it says here that it's 4.3 volts on the output of the function generator. Now, don't get too concerned that this says 4.3 volts and this says 4.225 volts. It's pretty common for things not to agree to that level of accuracy. So that's 0.05 volts out of 4.3 volts. That's 1 part in practically, that's less than a tenth. That's a little more than 0.1% or so. So that's pretty good accuracy. I don't think we need to worry about that. All right, so we can see that the amplitude is that amount. Now I'm going to move the probe down the voltage divider. So the output is, no, let's not do it quite yet. Let me make it so that it's a nice round number. We're going to make it 5 volts. So it's 5 volts, it says 4.9 volts. That's 1 part in 50. That's 2%. I changed this to 5.1, so this says 5.0. So now I'm going to move this down to the other side of this resistor, and now it says 3.8 volts. And if I move it down here to this resistor, it says 1.9 volts. So it's a voltage divider. The voltage is coming in. I'm using my oscilloscope probe, and I'm getting that. Now if I wanted to, I could show another voltage at the same time. I could show, if I want to, I don't need to do anything with the ground. Like I said, all the grounds are connected. When I connect it here, it is with respect to ground, which means this point again. So I have this here just for illustration purposes. Again, it's not necessary. If I remove it, nothing will change. You can see nothing changed when I disconnect or connect the ground. I chose to put the ground connector there just so you would see where the voltage was being measured, from here to ground and from here to ground. So if you look at the screen, you can see the blue curve, which is channel 2, and that is the output of the function generator, and the green, I'm colorblind.
Pink.
No, the other color.
Yellow.
Yellow, the yellow curve, thank you. I can do electronics, but I can't tell yellow from green. So the yellow curve is a lower voltage because there's a voltage divider and it's a lower voltage. Now, if I want to play around with it, I can change the horizontal, I can change the vertical on one channel. So that's channel 2. If I want to choose channel 1, I can change the vertical on channel 1. So as I press between channels 2 and 1, I'm just changing the scale. I'm not changing what's going on electronically. I'm just choosing to display different values. Okay, let's stop there, and I think that's a reasonable introduction to the oscilloscope and how things work, and should get you started.